Okay, so I'd like to introduce you to Christian Peel. Dr. Christian Peel is an electrical engineer and he runs the Ethereum meetup. I think he'll give more of an intro himself, but let's give a warm round of applause for Christian Peel.
So, great. So, I'm going to give a little bit of it, like maybe a half hour, a little bit longer, depending on if we have questions, kind of introduction to Ethereum, and then we'll have some code examples. So, and these are fairly basic, I think, and I'll give you pointers to get to those. So here are some links. I'll post these slides somewhere that you have access to them, so that you can look at some of the links we'll have.
Slack channel.
Right. Okay. So I guess the big question is what is Ethereum? So I don't know, maybe anybody that has kind of done a lot of research and that is completely an expert now, besides Chris. Chris, I think, knows what Ethereum is.
Are there any experts? Really?
What's that? Any experts on Ethereum?
Is there anybody an expert yet?
There's one expert.
Is that
Yeah,
Vitalik?
that's about it.
Yeah,
Right?
one person just has the whole thing in his head.
Well, I think there's actually a few more now, but yeah, maybe he's the one that has the vision. So yeah, we'll talk about Vitalik a bit. So I guess basically Ethereum is a platform for building and publishing distributed applications or smart contracts. So I just learned that your great instructor, Christopher Allen, had a smart contract company in the early 2000s. What is your one-sentence definition of a smart contract?
Basically, the ability to delegate the authority to enter into agreements with other parties in an autonomous way.
Yeah, and so I'm guessing that you're including code in this. Is that correct?
Well,
or is it
there's a
possible?
variety. I mean, clearly, there's code, there's resources, and you can. There's also a lot of things you can do with secret sharing, voting, other different types of permissions. Then, of course, there's a lot of things you can do with ledgers, and that's what Ethereum really focuses on, is the ability to back a smart contract through financial mechanisms.
Okay, very good. So Gavin Wood likes to emphasize the possible social aspects of these contracts. So his definition is that Ethereum can be used to create cryptographically enforced social contracts. Right, so these codes, I guess if you just want to think about a smart contract, it's a chunk of code that is sitting on the blockchain. It's like, you guys covered scripting, I guess. It's like it's a little script, but in addition to the scripting, which Bitcoin provides, you have the ability to store some data, and this contract can change its state and change send transactions and create and interact with other contracts. And it includes a Turing complete language. We'll talk a little bit later about the language in which you write these contracts. At least the main one is Solidity. There's a few others. We'll just focus on Solidity as the tool to write smart contracts. Okay, so lots of people like to emphasize the ability of Ethereum to do a broad set of things, such as currencies, derivatives, voting systems, organizations. So anybody know who Balaji Srinivasan is, or at least, okay. Is he? Okay, great. So, I mean, I think there's probably several people around by that name, but this is the guy who works at Andreessen Horowitz, and he was talking about Bitcoin, saying that the long-term impact may be to make finance fundamentally less profitable. And what he's talking about is the sort of things that are possible with Ethereum, implementing a lot of the things which are done by the current financial industry in an automated way using, smart contracts. Okay, so let's say we have a smart contract that is sitting out there on the blockchain. It's doing some cool stuff. What is to stop some programmer from doing something really computationally intensive and such that if we start up our Ethereum node, it just bogs our CPU down? Well, the answer is that there is a cost for executing these smart contracts. There's a cost for each instruction, or a price, I guess is the right word. And the currency then that is used in Ethereum is Ether. So some people have compared Bitcoin to gold, calling it digital gold. So then if you're going to follow that line of thought, then Ethereum, the Ether currency would be like digital oil or digital gas. There's even this gas parameters in Ethereum, which is talking about the price that it takes to execute instructions. So some contracts are going to take more, others are going to take less Ether. So Chris and I were just talking about Nick Szabo. Everybody know who Nick Szabo is? Anybody that doesn't? You don't know who Nick Szabo is. He's perhaps, he would, but what about Satoshi Nakamoto? You've heard of that name? Yes. So many people's best guess for the person who Satoshi Nakamoto is Nick Szabo. And he was perhaps the first person to use the word smart contract. He wrote some articles about it.
In 1994, he said, a smart contract is a computerized transaction protocol that executes the term of a contract. And the link is in the Slack if you want to see the original.
Okay, great, very good, thank you. So I've never met him, but I've exchanged a couple of emails, and one of the things which he was concerned with about Ethereum was that he wanted contracts to be able to initiate action on their own. But that's actually not the way Ethereum is set up right now, and it's a little tricky to make them initiate action on their own. You actually have to send the transaction to the contract to trigger its action. So yeah, sending the appropriate transaction to a contract causes its code to execute, and that contract can then, store data, it can send transactions, and interact with other contracts. So this can get fairly complex. You can imagine lots of, pluggable contracts. We'll briefly mention Eris, which a little later on, which has done a lot with pluggable contracts. Maybe other. At least that's one of the things that worked. Okay, again, we're going just through some high-level things here. So, we all interact with the web through browsers, and so the Mist browser is something that Ethereum is going to release as a tool with which, as a browser which has built-in connection to an Ethereum node. And I guess the idea is to make the user interface to Ethereum contracts quite a bit easier. You may do most of your programming in JavaScript, and then you interact with, you have this backend in Ethereum or some other tools. And we'll also talk about how you can use a regular browser. So, even if not all of you are developers, at least some of you are developers, and this complex interaction between JavaScript and Ethereum code could be a little bit tricky to debug. So there's an IDE, which I'll demo here in a few minutes, which allows you to debug both the smart contract code and JavaScript and other components of the Ethereum ecosystem like Whisper and Swarm. So it's got, syntax, highlighting, code health stuff. So you guys are super quiet, not a single question here, but so please speak up if you have anything. I'm happy to, please.
Oh, there's a question about Ether, and how do you get people to, how do you pay them through the contracts?
Right, yeah, great question.
Can you
So,
repeat the question?
How does Ether work with the contracts?
yeah, so with Bitcoin, there's a couple ways that miners get paid. So miners can get paid in transactions fees or by mining by a block reward. So instead of transaction fees, optional transaction fees that Bitcoin has, then Ethereum has a very explicit cost for each execution. So there's a virtual machine that we're talking about a little later on, and each operation of the virtual machine costs a precise amount. And when a miner wins a block, he'll get the reward for all of the contracts that are in that block. I don't know, does that answer your question? Okay,
We
please.
may want to just,
I'm sorry. So how do you get Ether in the first place, besides outside of like mining? Can you
Yeah. So there was a pre-sale. I'll give you some of the dates later on. Yeah, there's a pre-sale roughly last year about this time, and the people had the chance to buy it. That money is now being used for development, a foundation. None of it is actually going directly to the founders except for salaries. So depending on how you value it, there's like $4 to $18 million worth of Ether sold. So then after that, it'll all be mining. So people who bought that will get some. There's a little bit additional Ether will go out to pay the developers, and then once it launches, it will be completely mining. Same as Bitcoin. Please.
Oh, so why are Ether and gas separate? Why not just
Yeah.
Actually, the gas is just they're not two separate currencies. Their gas is just the term. It's like we have what is the right word there? Gas is just
Is it the cost of processing?
gas is gas is like the name that you might use to refer to Ether when Ether is being used to pay for a contract. So there's not two currencies.
to a certain extent, if you think about one of the things that a Bitcoin miner has to do is they have to basically validate every single transaction that it fits and that the answer is true at the end of the of the, at the end of the block before it's, in addition to the other tests they do. Well, with either, with these smart contracts, they basically have to do all of those calculations. And not only that, it's every miner has to do every single calculation on it. So there has to be some kind of reward for the fact that everybody is testing and doing all the calculations in a consensus way on it. You have to have a standard pricing for what it, what it means to go through that test, and that's the gas. And you pay for the gas with either, basically.
So if all the computers are doing the same calculations, is the network limited to the number of calculations one computer could do?
Yeah, well, I mean, the whole point of having a price there is that you're going to keep the. I mean, you're not going to be doing any computationally intensive, or at least not very computationally intensive. That's one of the whole reasons in the price. So you typically would be operating much below the capacity of for the computation, much below the capacity of a single computer.
Okay.
I mean, if it takes.
Well, that is like the limit. But
What's
it's
that?
well below, but that's sort of like the limit. Is like what the average mining
Yeah,
computer could
well,
do.
exactly. And so I haven't researched the proof of work a lot recently, but one of the ideas is that as part of the mining, you might need to be executing some random Ethereum code, which would make the mining effectively, to make an ASIC miner, you need to effectively make a general purpose computer. I'm getting a little bit off track there. Sorry, that does not answer your question. But yes, I think generally you're getting far below the cost of far below the computational power of a computer.
And so, is gas consumed and destroyed, or does it go? Is it basically a transaction fee that goes to the miner that wins the block in which that goes?
Yeah, it just goes to the miner. Yeah,
Okay.
you pay.
Okay.
You have you got to pay for execution of your code, and that goes to the miner.
Okay. Gotcha.
If you're running a standardized contract, you'll know prior to forming that contract exactly how much ether will be burned.
Yeah. So the ether. So this, right here, this mix IDE that I briefly mentioned here, I'm going to demo one which doesn't have the cost of the contract, doesn't explicitly list the cost, but more recent versions do have that built in. So right during your writing of your code, you'll know the amount of gas that will be consumed.
And that's for standardized contracts. What about for like idiosyncratic contracts? How will you have any idea whether you hold enough ether for your contract to be fully implemented?
Well, so when you send a transaction to the contract, you have to, the amount that you send and possibly plus some from the contract itself has to have enough for it to execute, or it's just not going to get executed. So if you don't send enough ether with your transaction, the contract is just not going to get executed.
But it might be problematic. You don't know how much ether is actually needed to fully implement.
No, it's a deterministic. I mean, you can look at you know that you can look at the transaction you're going to send. You can look at the blockchain. I mean, it's a complex process, certainly. I didn't quite catch why.
I don't. An individual contract isn't that computationally expensive. What your ether is really paying for is the fact that many people are doing it. Okay? But individually testing, how big, how much gas a contract is going to use isn't that hard. I mean, what's the largest contract in the example code? It's not that big.
Well, Eris has some really big contracts. I don't know I don't actually have a number, for example, in ether dollars, but yeah, they're small.
So are we essentially saying that the gas is essentially a transaction fee paid to the miners? That's pretty
Well,
much what
but
we're
yes,
saying?
it's a transaction fee that varies according to the amount of storage, amount of data you're storing, and the
Yep.
code size that you're
I get it.
executing.
It is a transaction.
It's
fee,
variable.
It's just a little more complicated.
You're saying it's variable, but essentially it's a transaction fee that we're paying to
Yes.
the Ethereum miners?
A non-optional.
It's not in addition to another transaction fee, it's the transaction fee.
Yes,
Okay, simple enough. Thanks.
please.
Do you have a change? So if you send too much gas, you get the leftover back, or?
That's right.
So
By the way,
Can-
Bitcoin doesn't have that.
can contracts run forever if the gas price is really huge amount?
Well, I mean, I think miners will be happy to take your money if somehow you run something computationally intensive, but yet you also provide enough ether to provide it, then yes, it'll run for. I mean, it has a Turing complete language, meaning yes, it could run for, but there's going to be a finite. I mean, you said forever, so there's a finite amount of ether out there.
Or
So
So is it a causality? I mean, is that the ether causing the contract to run, or is the contract running which generates an ether that's paid back? I mean, so when he asks this question, I mean, could it perpetually run if you perpetually feed it ether? I mean, are they independent of each other, or is one dependent on the other?
So just as a bit of a reminder here, you earn ETH. You could have bought ether at the pre-sale. Maybe if you do a little bit of development, you could get some ether for that way as well. And then you can mine it to earn ether.
Right.
If you're a miner, you can earn ether. That's the same with Bitcoin.
Yep.
Just think about the normal way ether is to be generated is via mining. That's the way you earn it. Now the way that you have to pay ether, you can use ether the way you use Bitcoin for monetary transactions. It might be that in the future you could use it in places where you use Bitcoin now. But you also need to pay it for transaction fees. So I'm not. Was there a
Well, the
specific?
gas. I mean, the gas. The gas feeds the smart contract.
Yes, yes.
So, but you
It
said
feeds
that
the
there was a price.
execution
There's a
of it,
price on the
not-
smart.
But you may have put in the transaction a whole bunch more either for what the contract is doing, which
Right.
for instance is an insurance or
Right.
a
So,
bet.
so the contract will run. If there was too much, it'll give it back in change. But there's no perpetuality to the contract. If I feed you an exponentially larger amount of gas than what the contract requires, the contract just won't keep spinning. It would just do its function, and then you would get change back, right?
Yes.
Okay. Thanks.
So if everyone's running all the contracts, what does Ethereum do for like private data or secret?
There's no. This is
No
like
secrets.
Bitcoin. There's no secrets at
So
present.
they're doing like a complex financial tool. I mean, everyone's financial data is available to everyone else.
Well, you hash it just like you can do anything else.
So it's the same way as pseudonym. Okay.
Well, yes. So you could be using. Let's say your. I think you guys had Spitzel here already. Anyway, let's say that you're doing something like financial derivatives, or you have some other financial things happening. I mean, it's going to be like with Bitcoin. You may be able to figure out who's doing things. Ethereum. You may be able to hide certain things with some hashes. The Bitcoin guys, the Ethereum guys are pretty willing to acknowledge the limitations of the blockchain model. For example, anonymity. There's no full anonymity, and they're at least aware of things like snarks, which could allow that. Cryptographic tools, which could allow that. So. Okay. All right. So I'll go forward then. So we have here is a graphical illustration of, of an Ethereum network. So the blue blocks are Ethereum nodes. The green circles represent some users of interest, or actually some decentralized applications. So yeah, the blue blocks represent the Ethereum blockchain. I guess, yeah, so together it's the blockchain, the blue blocks are nodes. We have other communication between, these applications using Swarm and Whisper. And I think, don't need to know anything special details about Swarm and Whisper, just except that Swarm is representing distributed storage, something like BitTorrent Sync. Anybody know what BitTorrent Sync is?
Yep.
Or distributed hash rate. So, and then Whisper is a communications protocol, a decentralized communications protocol, and they're going to be using keys that they're from the Ethereum blockchain. So they're building on top of Ethereum a little bit. But so Swarm would be used to store, bigger chunks of data, so you don't have to load up the Ethereum blockchain with your images or anything like that. And Whisper is used for communication. Okay, so in your app then, it's not just Ethereum code, but you might have some JavaScript, QML, or a front end in normal web front end.
Question.
Please.
If DApps and smart contracts are simple,
Yeah, so let's just stare at that. Let's talk about that a little bit. So, your smart contracts are going to sit out here. Think of them as sitting on the network, sitting on the nodes, and you're interacting with those over your back end. You'll have some commands in some JavaScript, for example. I'll show you some examples here in a second where the JavaScript is interacting with a local node through some commands that you can call. So here are the smart contracts sitting out here on the network. Here's your code that is going to be calling it. Here's the front end.
So where's the code stored? The HTML, CSS, JavaScript?
Well, that's going to be on your computer.
So every user of the application has to have it on their computer?
Yeah, so that's one of the reasons to have that MIST browser that I mentioned. That's one way to provide a common interface. But of course, they've also discussed, packaging up an Ethereum.js library, which could be used to interact with a node which is not quite so closely tied to the browser. So you might have, you get Ethereum.js interacting with a local node, or maybe even a remote node. You use that to interact with, the network.
so essentially DApps can HTML, CSS, so it can sit on web server and make a call to the smart contract. Right? If it's HTML, CSS, then essentially can sit on the web server, right?
Yeah, so just to be clear, the back end here, so this, I didn't make this figure, so I'll just give you a little bit of perspective on it. So let's say, in my mind, the back end is implying a distinction between your browser and the server. So normally when we go to a web server, it's not on our own computer. We're going off to somewhere else. And so the server is providing this stuff is sitting on the server. Here's our front end. This is our local execution. So one of the points of, one of the possibilities with Ethereum and other applications is that there's not really much of another server that you're going to. So there's the possibility of all of this stuff sitting on a local computer, including your node, and there's all this stuff which would normally happen off on a server can happen locally. But of course, if you've spent any time around Bitcoin, there's lots and lots of Bitcoin operations and tools that are using servers. So with Bitcoin, even though there's the possibility of doing lots and lots of things locally, there's still a lot happening on servers. I don't know if that answers your question at all. Does it help out at all? Okay. Okay. So I did. I have a little mention of IPFS up there, which is a fun thing to learn about. I don't think I'll mention it further, but if you have time, look up IPFS. Okay, so we could ask, what is Ethereum? So there's lots of different potential answers, just to kind of recap here. So there is the Ethereum blockchain, with the distributed apps and smart contracts interacting with it, smart contracts on the blockchain, distributed apps, interacting with it. There's the Ethereum Foundation, which is funding some developments. There's this Mist browser. To some people, that may be Ethereum to them. There's the currency. There's some languages. It might, if you're kind of abusing notation, you can talk about the Ethereum languages. Then there's these combination of tools. There's Swarm, Whisper. There's the IDEs, some other tools. And then there's the community. So, all of these are on Ethereum to some degree. All right. So yeah, just kind of recapping a little bit, just for fun. Let's look at the history. So, Vitalik Buterin has been working on Bitcoin off and on for several years. In a year and a half ago, November of 2013, Vitalik started circulating a white paper. And a few months later, they came out with the proof of concept. Had a pre-sale in July of last year. There's been a bunch of proof of concept clients come out. And now we're to the point, close to the point of coming out with the very first release, not quite a full release, but a preliminary release of live software. And this is just me guessing now. Nobody has put these dates there, but me just guessing. Maybe in late 2015 we'll have the homestead where the mining is turned on fully. The full release may not be till 2016, and there's lots of discussion about what will happen later on. Okay, so some final, let's see, where am I at here? Okay, I got a few more things here. So, maybe this is a good time to ask for questions, please.
Yeah, it just kind of goes back to the beginning when you said that transactions were needed or required to, I'm not sure if I have the word right, execute or start a smart contract or the kind of.
Right.
Is it required to send Ether as part of that transaction, or can you do a transaction without Ether to execute?
So I think what happens is that the person who sends, so I'm I'm not pretending to be a full-on guru. I'm just like, this is just like my hobby,
Okay.
running the meetup. I'm not a developer, core Ethereum developer, and I don't even write very much code except for the stuff I'm going to show you in a minute here, which is not very complex. My understanding is that the person who sends a transaction has to send enough to execute the contract. And the contract itself is going to have its own account, which includes an ether that it'll have. So when you send a transaction, you got to send enough ether to execute the contract and possibly, do some other things as well. Let's say you want to, since maybe there's money ether required in addition to the contract execution.
Okay, I understand. So, contract is compiled and deployed into the Ethereum blockchain.
Yep.
It needs Ether in the first place, right?
Yes, it needs to have, there's a cost to deploy it, yes.
Okay. And then to trigger it, you need to send some Ether.
Right.
And you're sending it, and I'm assuming that this contract is when it's compiled, it's going to be an address, something. Right?
Say that again. What's
So how will we know? I mean, we call this smart contracts like a DApp is trying to initiate call to a smart contracts, like with an Ether. How does it know what contract, the address, and so on and so forth?
Well, I mean, how do you know if you're going to send some money to a Bitcoin address? How do you know what that address is? What's that?
Basically the address.
How do you know how do you, right now, how do you know what Bitcoin address to send money to if you're sending?
Somebody will provide you the address.
Right, so it might be that when you deploy the contract, you'll know the address. It might be that for certain applications that it's just publicly known. This Mist browser that I mentioned earlier, the idea is to include in that like a store of applications, and so you may kind of like your app store for your phone. There'll be a little library of applications that you can go to. This would be the front end, all the stuff. This browser would not be downloading the contracts, which would sit out here, already be deployed. But when you write a decentralized application, you might stick the contract out there, do a little bit of testing with it to make certain it's doing what you want. Then you publish your interface, the rest of your app, using these yet to be fully defined tools, which will allow other people to see what they are. And that could include in a very user-friendly way that hide all the addresses, include but hide the addresses of the contracts, etc. Please.
I noticed that you already started mining, and at this point you already have around 700,000 blocks, right? It's on your website.
Well, yeah, just
So I'm just trying to understand. You said it's still not possible to buy Ethereum, but I see some people are doing the transaction with Ethereum.
right. Okay, so they're doing kind of a gradual ramp up. So right now, I don't think that they're getting anybody is getting rewards for mining. But yes, there are nodes connected to that. Yeah, let's see.
41 nodes right now. Is that
Yeah, let's see. Let's just see if I can find that address here for you guys, just so that we can. Right, stats.eth.
I can put it on Stack.
And this is not live because I don't think I've connected to the internet, but this is roughly what it looks like. This is what you're talking about, I believe. Is that right? So, yeah, the idea is that, yes, we're getting all ready to start launch, but it's not yet fully launched. So when it goes live, yes, this will be the page. So this is still a test net. But there are rewards for things like fixing bugs and so forth, and very soon there'll be mining rewards when the frontier launches, according to the calendar I gave you a second ago.
Well, what's Uncle now?
Yeah.
Right. Yeah. So with
I can explain it if you want.
with Bitcoin, it's always the longest chain, and it's a little bit different with Ethereum. Please go ahead.
So if there's a contention, there's a delay in the network or whatever, in Bitcoin, it basically, somebody can keep on mining them thinking, oh, I've actually won the block, or I'm going to win the block or whatever, and then, oh my gosh, in fact, somebody else has the longest, I'm winning, and you have to, the confirmation changes. With Ethereum, you can actually take advantage of the fact that other people are doing blocks after you. So you can basically have an uncle that did all the valid stuff, and even though it thought that it was based off of a different set of blocks, it can actually, some of that work that is done can now be brought over to the correct blockchain. It's basically a way of preserving the efforts of the miners who maybe have gotten off track of the main effort.
So like we merge different lengths, different chains.
Yeah.
So a lot of uncles bad thing. Like you want it to be merging down to none.
Yeah.
Well, the ability to kind of use the fact that there are uncles is a good thing. I mean, that's making it more robust. But yeah, you do want to converge.
Yeah, they're orphan blocks that have some utility to make it easier, and they get some credit for it. So they don't actually get to win the final thing, but they can get some of the Ethereum for having made it easier for the world.
Can I just ask, when you said contracts can't be automated, or a transaction has to be sent to initiate the contract.
That's right.
So that doesn't mean that doesn't mean a human has to be involved to send that transaction. It can be conditional on an event occurring that is linked to a feed, for example.
You have something like running on a traditional server that triggers the contract.
Yeah.
Like a centralized thing that can trigger it, but it's your own service. So, yeah. Is that what you mean?
But that has to have enough ether, right?
Yeah, so I get like a server set up that's got like an RSS feed and an Ether wallet, and it just looks for things and then triggers contracts based on things.
Yep.
That's right. Yeah.
And that is possible.
That's the question.
That's my assumption. I have.
So let me see if I can just give you an example. Let's say this is you here. You have a transaction that you made. Let's just talk about. Let's ignore the rest of this. Look, you have a contract that's sitting here on a node, and you have something that you want to happen at a given time. Well, it can't be just these nodes themselves. It can't be triggered strictly off of a blockchain-based entity. It has to be, one of these other guys here monitoring the blockchain, monitoring meat space, and sending something. It can be a computer or a server doing that.
And if you keep constantly doing that, right, there is no limit on how many times you execute the same contract.
Well, if the contract, you can actually suicide a contract. It's possible to kill a contract. Assuming that you keep, that the contract is coded appropriately, and you can keep it going forever.
Are there things like oracles in Ethereum where a contract can go out and get information about something, external information, like price
Well,
feed
I mean,
or-
the way that you implement it is kind of the opposite way. You take, I mean, so all these things like derivatives that we've talked about, and maybe other things would require external entities to put information onto the blockchain. You can call that an oracle in some sense, but it's the other way around. That entities on the blockchain don't go off and get something off the blockchain. You, people off the blockchain, put it on.
So when I trigger the smart contract, I'm triggering it with information.
Well,
that it
you're
uses?
sending a
Like I tell
transaction.
it run, and then I send it data also.
Well, yes, you can send data to it.
It needs to know like what the price of like milk is, for instance, say.
Right, so let's say that you have a derivative that is based off the price of milk. So what would happen is that you might, hopefully Bloomberg or maybe somebody else will have their own feeds. They'll be putting the price of milk onto the blockchain in a known place, in a known contract, which they're publishing the address to. They're, you know, maybe they're doing it, you know, once every 10 minutes or, you know, whatever, with whatever frequency. And you are sitting in your, you know, you're watching this feed. You can monitor the blockchain, and when you see something favorable, you want to execute a derivative or whatever transaction based on the price of milk. You fire a transaction off at the contract with enough money for it to execute, maybe with enough ether for the derivative.
So if you had one that was like a really cheap smart contract and you gave it ether just so it kind of like idle run and watch that data feed on ether, could it just like be running, burning gas, watching the Bloomberg price feed, waiting for something to?
But why would you want to do that? Why can't
So you don't have to have your own server running, it could be like just entirely decentralized? I mean, I know it costs money, but it could be like a low idle, where all it does is just look at Bloomberg, is the price below 5? No. Then just keep checking what the price is, because you can see that on Ethereum, and it just has its resource of ether. It's like I'm paying for server costs also if I'm doing it myself, you know. And then it waits for the price to do something, and then it tells another smart contract, okay, do your more complicated thing now.
So you should. So just a reminder, it's, you know, the code that you're going to be executing. Think of it as like, you know, the sorts of code that could run on like, you know, the very first cell phones.
Sure.
So you're not running anything at all very computationally intensive.
Right.
And so it's almost certainly going to be much more cost effective for you to either eyeball the price. I mean, it's going to be more cost effective for you to use some other mechanism to monitor the price rather than sending.
Bloomberg, you were saying Bloomberg is submitting the data to the Ethereum blockchain.
Right.
What's the benefit of being on the blockchain if I'm external watching the price? I could be getting it straight from a Bloomberg or API feed. I'm going to be looking at Ethereum. It's already on Ethereum. My contract can see Ethereum.
Well, I guess the point is that.
Can I have a watcher contract?
So let's say, I mean, generally with derivatives, you might take the average of multiple price feeds. So you want to kind of remove, or maybe the median of some price feeds. You want to remove the centralized world, so you have some different price feeds, and that's one answer. You also, and the reason to do it on the Ethereum blockchain is that all the logic for the derivatives can be done in a decentralized way. Hopefully it's going to be lower cost to execute your derivative using Ethereum than it is to execute it
But I'm
through a
executing
centralized service.
But I'm not doing it that way. The way you described it, I'm executing I have a server somewhere that's watching the price feed, and it's saying, okay, now is the time to act. Like I'm actually doing that logic out of Ethereum.
Okay, well, so I don't pretend to be a derivatives guy, but let's just try to imagine how this is going to work. So in a derivative space, there's several parties. There's two people that want to enter into some agreement. And then there's like a clearinghouse that is the people that matches us up. Let's say you and I wanted to enter into a derivatives contract, but we don't know the way that we find each other is through some clearinghouse in today's world. That's a centralized service. They're going to charge us a little bit to introduce each other, some kind of fee. And the idea is that that clearinghouse could be implemented in a distributed way using, Ethereum and other tools.
Okay.
Oops, please.
So, and this maybe builds on what you're saying. So the thing that I struggle with most about smart contracts is two things. First, you always have to trust something that is outside of the contract itself because it's coming into the contract. So an example is you have a smart contract that has a structure that allows some sort of computation to occur based on some outside event occurring. If the contract is between two parties, you first have to agree that the origin or the Bloomberg terminal in your example is a trusted source, right?
Or that you're using the median of 3 or 5 or 20 different feeds.
Whatever, it could be anything. It's the source between the two parties is an issue in and of itself that both parties need to trust it. So just to execute the transaction, you have to deal with that issue, and then the source will change over time, right? We could say theoretically the Bloomberg terminal is always going to be here, and we are always going to pull, we're always going to execute a transaction based upon, whatever price is out there. But things change, right? So the source could change over time, which means that the foundational aspect of your smart contract would change. So I just struggle with these sources, these oracles, whatever, getting people to trust them is a challenge in and of itself outside of the construct of the smart contract. And you could have this beautifully designed smart contract, and then the source is crap, and so the smart contract is crap. And that is happening outside of this construct, right? And it just seems to me like we're going to have a lot of troubles about having trusted sources.
Jeremy, I think maybe one of the things that you're missing here is you're thinking of this as being, an A plus B equals C type of situation. It's a lot richer than that. Right now you have a contract and it says, that you were supposed to use a derivative from an insurance company that's no longer around anymore. What do? You amend the contract. So this isn't that much of a different situation. The fine art of how to create a sophisticated smart contract isn't going to be one perfect equation that does things. It's going to be a bunch of interlocking equations, different things that send inputs from one into the other, different things that will basically say, okay, here's this root simple little contract that all it simply says is, which other contract are we using now?
Yeah, but Christopher, contracts are binary. They're either going to work or they're not going to work, right? So, at the end of the day, you may pull from a lot of different places, but at the end of the day, the script is either going to execute or it's not going to execute, and that's going to be based on the source of the information.
But as long as you and the other party agree that that's my source and you're both comfortable with it, and you enter into the contract, which is proof that you're okay with it, what's it really matter?
And if you're worried about the risk, you can embody that risk in the contract to basically say in these when the oracles don't agree or the oracle is not up to date, under these situations, we go and do a different contract that allows us to vote on who the new oracle is going to be.
I totally agree, and what I will say, Christopher, is that in everything that I have read in this subject, you are the very first person that has articulated that specific issue. It seems to me like that is lost in the discussion. The discussion is about the beauty of constructing these beautiful smart contracts without the necessary thinking around when Oracle breaks, what do we do? Like that isn't part of the conversation that I have seen. And so, I mean, that's why like I see this stuff and I love it, but I'm always like looking at there's gonna be a beginning to the contract and the transaction, and that thing can break, and if it breaks upstream, everything downstream doesn't work,
Oracle's gonna be a huge loophole.
right?
I just think it's, again, it's
I'm
parallel
not
to
sure
the
where that's
legal
different
system.
than entering into a manual contract with anybody.
Yeah,
It's
but
the
you're
same
supposed to be able to
situation.
try to do these at scale, Dave.
Yeah, the idea is that you don't have to.
The idea is that we
We're
can do it
automating
a million times.
Yeah.
You know what I'm saying? That's the idea. Like
I have
you
a-
can do
The
this at
selling
machine
point is
scale.
that this simpler things you can do, but it's simple, it's automated, that's the selling point.
I get the automation,
Yeah.
all I'm saying is we don't live in a perfect world, and I would think if I entered into a contract with an intelligent, advised person, that I think we would think of these things the same
Like an
way.
ex-
And
Yeah,
we're
like an
aware that
arbitration clause.
it's not a perfect world of things right now.
So to build on that a little bit, I mean, so Gavin, I don't know if you guys remember this, right at the beginning, we talked about it being, yeah, I mentioned the fact that Gavin Wood called these cryptographically enforced social contracts. So, you know, even though it looks like, you know, if you're sufficiently nerdy, you just love the coolness of this idea, and you're thinking about Skynet, and, you know, it's just, you know, beautiful, but, yeah, so it's definitely people on the end.
But you're articulating as commercial contracts. I mean, your examples are derivatives. I mean, those are commercial by nature, right? So, I understand that he's saying these are social. It's a social contract, but we talk about it as a commercial contract. I'm not quite sure, like.
Well, okay, so we're not actually, yeah, I'm sorry, and what I meant, so when I said social, I meant that it's people involved. There's failure, there's
Okay.
there's
All right,
problems
that's fair.
involved. It wasn't like a social contract in the sense, I mean, yes, you could think of it in the sense of the social contract with people, but I guess the whole point is that there's failure involved. You need to plan for that, so you can have, let's say if you make your derivative, you can have several layers of safeties built in. Let's say that you, in your derivatives contract, which is matching people up, it can have an address, instead of having the internal feed internal to it, it's likely to have an address to an external aggregator of feeds. And that aggregator of feeds may also have the ability to control which feeds that it's monitoring. So when you're out there looking at your deciding, you might have multiple contracts, multiple places to go for your derivatives contracts, and you just pick the one which has a trusted feed. You
No,
monitor.
I totally get it. I totally get it. I mean, I like Christopher's example. I think that's well articulated. I would say my perspective is the ability to trust the Oracle is in itself a fundamental issue that will determine the success of the platform. Because without the ability to structure oracles and the ability to manage them and change them and address issues that happen with them, then the contract itself is suspect from like an auditor's perspective.
And it does run in parallel with the legal system, but until you know how the legal system is going to respond when you move from the Ethereum world to the actual real world, until you have some examples of how the legal system is going to respond, you just don't know what's going to happen. And so what commercial entity is going to enter into one of these contracts until they know exactly how it would play out in the court?
So we need like some examples of there being a mistake, it's bad data, and the smart contract, it's like saying, okay, we're going into arbitration, and you guys decide this yourself. Like, give me an example of that working, this idea that there could be safety and failure.
I would argue the same thing happens today in the manual world.
Sure.
Alrighty, guys, I think
Again, I'm missing the point here.
I'm
It's the same thing.
I'm like I was enjoying the conversation, but
Sorry,
we gotta cruise ahead here. So, okay, so I'm gonna just whip off a few minor things here. Ethereum uses proof of work. It's got a block time of 12 seconds. You can go back and look at these things a little bit later on. Here is a page of some resources for you. These are links that you can look at on the PDF to help you find, just to keep track of things if you want to do some development on Ethereum. So, one of the big examples, or big questions that you might have, let's say that you're, if you want to start a little startup company on Ethereum, one question might be, should I use Ethereum or should I just use Bitcoin? Well, if it's just purely currency based, there's a lot more tools for Bitcoin, you should stick with it. And even if you're ambitious enough, you have really ambitious smart contract projects, there are going to be problems with Ethereum. And it's just raw, it's not released yet, there's lots of problems, you should be aware of that. Okay, you guys can come back. So I have a few examples that I was going to go through right now. There's a link to them right here. Here's a link to the examples, GitHub repository for the examples I'm going to show you. Here's some email addresses for people that might help you if you have specific questions on technical aspects. I may be able to help you, but for anything that's very complex, you probably need to ask them. Great. So, and there's finally a list of some companies that are building on Ethereum, including, I'll just mention, one of the, as we've mentioned before, one of the exciting things is getting contracts interacting with each other, rather not just single contracts interacting with off the blockchain, but multiple contracts. So Eris has worked a lot on that.